we're going to draw a histogram, and what we'll do is let's pretend that I were able to get all the scores of last Tuesday's monster test, and I just want to know, you know, hey folks, how did that test go? So we're going to use a histogram to visualize how that test went. And so I've got, oops, I meant to grab my pen. Here we go. Here I've got all the scores on last Tuesday's monster test. And just looking at that, it's hard to tell. I don't know. Did it go well? Did it go poorly? But we're going to create a histogram, and that'll show pretty clearly what went down. So, step one for drawing a histogram is to decide how you're going to organize the data. What are your bins or buckets going to be? And those are the ranges of values. So, for me, the most natural way to do this is to put all the F's in one category or in one bin. So any score between 0 and 59 points out of 100 will be an F. So this will be our F bin, and then we'll do 60 to 69 will be the D's. So these are ranges of values. Anything between 60 and 69 is going to fall into this range. Um, and I'm just assuming a 10-point grading scale. Maybe you work on the 7-point scale, maybe something else. So 70 to 79 will be a C, and 80 to 89 will be a B, and then 90 to 100 will be an A. So we're going to put each of these values into its appropriate bin. And the way I want to do this is I'll put a tally mark for each one, and then I'll cross it off once I've put it into its appropriate bin. So starting with 15%, 15 out of 100. Ouch, rough day on that test. So that's an F. That's between 0 and 59. So I'm going to put a tally mark there, and then I'm going to cross that out. 60, that's a D. Not so great. Better luck next time. 89, solid. It's a B. 89. 23 is an F. 44 is also an F. That's between 0 and 59. Sorry. 56. Ooh, almost not an F, but it's an F. So 56. 79. That's better. It's a lot better. It's a high C there. So I'm gonna put a tally mark there for the 79. 100. Nice. Crushed it. So put a tick there and cross that out. 20. Bad day. 11. Ooh. Not good. 5. I don't even know how it's possible to get a 5% on a test, especially if it's multiple choice. Anyway, just wasn't happening. So 5. Let's see. Did we mark that down? I got to stop talking so much so I know if I've marked it down. Let's see. 1, 2, 3, 4, 5, 6. Yeah, mark down the 11. Okay, and then 5. There. 34, another F. 78, it's a C. 23, it's an F. 99, awesome. 56, it's an F. 67, D. 53, F. 68 is a D. 71 is a C. 82 is B. Nice job. 34, ouch. 24, double ouch. 79, oh, almost had a B. 11, not good. 91, A, awesome. 23, 42, ouch. 67 is a D. 45, 89, B. 100 is A. And then 23 is an F. Okay, so let's count up how many values fall into each range. So the F's are 5, 10, 15, and then 3 more is 18. D, 1, 2, 3, 4 values, or 4 scores fall into that range. C, 1, 2, 3, 4. B, 3. A, there's 4 A's. Okay. So now that we've um, got the frequency of each range, the frequency that values fall into each range, um, now we can construct our histogram. So we've got two axes. And the y-axis, I'm going to do frequency. You always do frequency on the y-axis for a histogram. So our range of values here for the frequency is, from 3 to 18. So what I'm going to do is, let's just go by fives. 5, 10, 15, 20. That'll allow us to record those frequencies, and let's label it freak. Okay, and then let's put our bins here. Now, it's important that the width of the bins is proportional to the size of the range that each bin represents. So here, the F, that's the biggest range. Anything from 0 to 59 points is an F. If it's a 12, it's a 58, it's all Fs, unfortunately. So that's a big range. So, all these ranges together represents 40% of the total range. So 0 to 100 points is the whole range of all the data. A D to an A is 40% of that. And F is 60% of that range, everything from 0 to 59. So I want this bin to be about 60% of the width of my x-axis here. So I'm just going to eyeball it and say my F bin is going to be about that wide. And then the D, C, B, and A ranges are all the same size, basically. So a range of 10 points. So I'm going to make those all the same size. So we got the D's, C's, B's, and A's. We'll go here roughly. And I'm just doing it. This is a rough drawing. You can be more precise in yours. So just give you a basic idea. So now we've labeled our bins here, and now we can go ahead and draw the bars to make it a histogram. So there were 18 F's. So this F bin will reach about this high. If this is 15, and this is 20, 18 is going to be something like that. So, and I'll make it the width of my bin. So those are the F's. And then D's occur 4 times, so slightly less than 5. So I'm gonna, let's say it's about like there. C's have the same frequency. It's 4 C's. B slightly less, it's 3 B's, and then A back up to 4. So that's my histogram, and I can look at this and say, gosh, a bunch of people got F's. That's not good. That's probably that's not the student's fault. It's probably not an issue of comprehension of the material per se. It's probably, I would maybe look at how was the material presented. Probably was presented in a way that didn't really make sense to most people, or a lot of people in any case. Or maybe the test was very confusingly written, something like that. Or maybe the students slacked off and didn't study at all. Maybe it could be that, but probably not. Probably I would say there's probably something wrong with the test, or maybe the material needs to be presented in a different way. So a histogram allows you to take a set of data like this and turn it into a meaningful visualization. You can look at this and just eyeball it and instantly see that the bin of F's gets the highest frequency by far. So that's not good. And I guess we should label our histogram. Scores out of 100. Scores out of 100 per student. All right, that's it.